Hey everybody, and welcome back to another video in this series. So I do want to make a quick apology real quick. I want to say sorry for my previous two videos. When I look through them or I try to, like analyze them to see if there's anything that could be wrong with the previous traversal videos, I just feel like I've been speaking crappily about those videos, and I'm really hoping that with the way I've explained things that it makes sense to everybody in those previous two videos to understand like what we did in step 1 and the step 2 series. So if you're definitely confused about anything in regards to that, I would greatly appreciate it if y'all can leave me a comment, like asking questions or whatever of what you're confused about, or maybe if something's not working even after like copying from this to see like how it all is going together. So in regards to that, I will say I'm going to try to get my A game on with this video and go over step 3 with y'all, because this is where the real meat of the video is going to be, or at least the traversal system is going to be. Because what we're going to be doing in this one is we're going to be creating our tracing from our character to the front ledge, from the front ledge to the back ledge, and from the back ledge to the floor, all around our level block, or our level block traversable. So as a quick recap, basically what we did in the first video is we cached some important values, right? Like we got our actor location using this built-in node. We got our forward vector of our actor. We obtained our capsule radius and our capsule half height of our character. So basically our capsule components half height and radius. We also looked at how to establish data-driven console variables within our default engine ini file and set those appropriately. And then in the previous video, we looked at doing a trace from the actor's forward direction to find a traversable level block in front of us. So that's pretty much kind of what step 2 was about, was like, hey, using the forward trace distance, it's like, do we find a level block in front of us? So that's pretty much what's going on here. So in the third one, the third step, the meat and potatoes, is we're going to go ahead and do our debugging or our line trace in order to appropriately put together what action or what animation that we will be taking in the next video, or at least putting those together. So let's go ahead and get started, guys. So the first thing that we're going to do, and I will say you're going to be getting a lot of traversal check results. So you should have had this already made, but essentially you're going to see me pull out a lot of the traversal check result for this video, because we're going to be breaking it apart to get specific information and then setting the new updated values back into the traversal check result. So by the end of this step, we should have a lot of updated values for our traversal check structure file. So let's go ahead and get into it. So I'm going to drag my traversal check result into the blueprint, and I'm going to drag off it, and we're going to do our break traversal check result. I'm going to hide all the pins, because as we go through this, we don't need every pin showing. So when we break and when we set our members to the traversal check result, we'll be doing a lot of hiding unconnected pins, because there's only going to be specific ones we need. So for example, what we'll be doing in step 3.1 is checking if we have a valid front ledge. And if not, we're going to fail the traversal check and go into a jump instead. So what we're going to do here is we're going to check off, after we've hidden everything, is the has front ledge, because we're going to set a condition to whether we continue or fail it in the beginning. So off that, go ahead and get a branch node and connect has front ledge into the condition. And then what we're going to do is up here, go ahead and grab the return node, and you're going to paste it in here. And off the false condition, we are going to return node that we failed the check, right? Let me clean this up a little bit. So this is essentially our step 3.1 right here. So I'm going to go ahead and copy paste my comment for y'all in case y'all want to copy it down. So going over it, our step 3.1, that if we find the traversable level block has a valid front ledge, we're going to then continue off of it. But if we don't find a valid front ledge, and this is what we were looking for in here, if we find a level block, and then in here with the transform, if we discover a front ledge. So by going off of that, if we do find that, then what we're going to do is start our first trace. So I'm going to go ahead and put this up here for us and just kind of set that there for the moment. So I'm going to go off into a little bit into the big space, because this is going to be a pretty big thing that we're going through, right? Because there's going to be a lot of checks that we have to do here. So the first thing we're going to do is we're going to drag out our traversal check result, and we're going to break it to get specific information out of it. So go ahead and hide the unconnected pins, and what we want to display only is the location and the normal. So what we're trying to do here is we're trying to get an ending trace here, and I'll show you like how that's going to be like when we set up the capsule trace. So we're trying to look for the front ledge location and the direction the front ledge is facing. That's what this normal is. So off of the front ledge location, we're going to drag off and look for an addition node. And then on that addition node, we are going to add another vector, and we're going to leave this alone for the moment because there's a reason why we need 3 of these input pins. So now the front ledge normal, we need to drag off and look for a multiply pin, because there's going to be an offset that we make using that multiply pin, and we're going to connect it into the second vector input. So off of this, go ahead and convert that second input pin in the multiplication node to a float, because what we're going to do here is we're going to grab our capsule radius, drag it onto the field, and we're going to then drag and look for an add node, and we're going to give it an addition of 2 units. So what we're trying to do is we're trying to scale the front ledge normal to point away slightly from the ledge. So we're trying to give ourselves like a buffer with the capsule radius. So essentially, like, let me drag over what we're trying to accomplish. So I'm going to drag over my other project real quick just to show you. So if I have my level block here, and I've already highlighted a ledge that will be kind of like our pseudo front ledge at the moment, what we're trying to do essentially is, when you look at it from the side, we're trying to set the capsule trace out from the ledge like ever so slightly, so that way it kind of avoids clipping and stuff like that. So going back into it, so that's what we're doing with that. So I'm going to drag our pin and connect it to that multiply node. So now the next thing we need to do is we need to grab our capsule half height, and we're going to do the same thing. So go ahead and copy that addition node and put it and paste it right next to the half height, and then connect your half height into the first input pin. So from here, what we're going to do is that third addition node, or the addition node that we have up here, the third input pin, we're going to split the structure, and we're going to connect this into the Z of that. So with our capsule radius, we're trying to give it an offset so that way it our trace point, or our sphere, or our capsule trace comes away from the ledge a little bit to give us a small buffer. What the capsule half height is going to do is it's going to then put it up by 2 units to be up away from the actual point of the ledge. So really what we're doing is going like 2 over and then 2 up, so then our capsule trace will be like right here, or just a little bit diagonally away from the front ledge point. So that's what we're really doing here for the start. So in saying that, let me go ahead and give y'all the comment node so that way y'all can copy that down. Let's see, comment, okay. So right here with the first part, we're trying to get the front ledge location and the direction that the ledge is facing using the normal. And then in the second one, so here, the front ledge normal is scaled by the capsule radius plus 2 units, which pushes the point away from the ledge by the character's capsule radius plus a small buffer, which helps place the tracing start point slightly in front of the ledge. Move that here. And then finally with our capsule half height, let me get that comment node for y'all and then paste it in here. So with here, The front ledge normal is then scaled by the capsule half height. It looks like I just kind of copied and pasted verbatim, but basically half height plus 2, which pushes the point away from the ledge in an upward motion, or in an upward direction, due to where we have the pin, the output pin plugged into, because we have it in the Z over here. So it's gonna, for this, it's gonna push it out, and then the half height's gonna push it up. So that way we're kind of like diagonally from that point. So once we have that beginning part set up, what we're going to do now is we're going to then right click on the addition output pin, and we're going to promote to local variable, and we're going to call it has room underscore check front ledge location. Just like that. Not sure why it did not change. So that's what we're gonna do. My bad, guys, because what ended up happening, I see what happened. It wasn't gonna give me the same name for it. So I tried to make this video previously and my computer ended up crashing. So I had gotten rid of all the steps, but I forgot to get rid of all the local variables assigned to it. So continue doing that. You're just gonna see me drag the stuff out and put it in here. So I do apologize for that, because I was trying to get this video out to y'all relatively early, but stuff ended up happening. The microphone was messed up, and like my computer crashed and didn't fully allow me to complete the video. So go ahead and create a local variable called has room underscore check front ledge location, just like that. So then what we're going to do is, off of that, we're going to then get our capsule trace by channel, and do the first one, the capsule trace by channel, not the multi one, and drag the execution pin into that capsule trace. So what we're going to do now is we're going to grab the actor location and bring it up here and connect it into our start, because we're starting this trace at our actor location, and then we're going to be doing this trace at the front ledge location. So what you're more than welcome to drag off into the end point right here, so that way it just kind of looks a bit tidy and you know where it's going into, or you can drag it from the local variables and connect it that way. You're welcome to do however you want. This just seems a little bit more smoother in my opinion. So with doing that now, we're going to go ahead and set our radius and half heights up. So we're go ahead and drag in your radius and your half height, and connect your radius to the radius and your half height to the half height, because now we're making the size of the capsule. And then what we're going to do now is I'm going to go up and I'm going to grab this and copy this, because we're going to be making 3 separate capsule traces, and you're going to have this at every point. So I'm just going to go, instead of recreating them every time, I'm just going to copy and paste them in. So plug that into your draw debug type, and then expand this and put your duration into the draw time, just like that. So we've just now completed the beginning part of the first capsule trace. So again, what we're doing is we're starting the trace at the actor's location, and we're going to end it where we have set up our ledge location plus a little bit of an offset, so it's a little bit away from the front ledge, so there's no clipping involved. And then we're setting the capsule trace to our radius, our capsule radius, and our half height, and then we're setting up our debug here. So now the next part that we need to set up is our out hit. So go ahead with the out hit. We're going to split the struct pin, and there's going to be 2 that we get. So first, go ahead and right click into the gray area and look for a NOR boolean, because I'll show you what we'll be checking for in a minute. So after that, grab a branch and connect the NOR branch into the condition, just like that. So what we're going to be checking for, and go ahead and plug the execution pin into the branch, is we're going to get our out hit blocking hit and connect it into the first NOR pin, and we're going to get our initial overlap and connect it into our second NOR pin. So essentially what we're doing with this NOR pin is that we are ensuring or checking that if we are getting blocked by anything, or if there's anything overlapping us, when trying to look for that front ledge location. So for example, let me bring over the level block. So if I scroll out and go to the side, so basically what we're checking for when we do our trace, so imagine our character is right here and we're tracing to the front ledge right here. What we're checking for is to make sure that there's no overlapping collision blocks or anything like that, or we're checking to make sure there's not a wall in between us, because for characters right here and we do that trace and we hit a wall or we overlap with something, then what we're trying to accomplish is that if any of those NOR values are true, then we are going to fail the check and we will be doing a jump instead. However, if both of those values are true in our branch, then we're going to continue onward to where, hey, we're not being blocked, we're not overlapping with anything, we found the front ledge, continue on to the next capsule trace. So that's essentially what we're trying to do there. So, and that being said, let's go ahead and drag out our traversal check result, and we are going to then set our members. So as I mentioned earlier with the set members, basically what we're trying to do is we are trying to then say, like, we're trying to update our values in the traversal check. So what we want from here is we want to then get our, let's see, where's that, has front ledge, just like that. And then let's go ahead and grab our return node, copy that, and paste it in here to where what we're doing is if any of these conditions are false, or if any of them are false, then what we will be doing is off the false, we will fail the check. We will say like, hey, we have not found a front ledge, and we will fail the traversal check. Just like that. So let me go ahead and copy my comments for you guys, just because we have now finished the first major trace, and so I want to get this kind of moved out of the way for the moment. And what I'm also going to do is let me prettify that up real quick, just to kind of have them looking nice ever so slightly. And then let me grab the big boy, the big chungus text block, and I'm going to move that into here. Just like that. All right, so now that we have finished that, let's go ahead and move that up here. And what we're going to do, and I'm going to route it a little bit, is let me move that down and connect your true pin from the branch in our first step into the set check front ledge location node. And then go ahead and set your pins if you want to do that, just like that. So now we have completed the first major capsule trace of this section. So now we're going to go into the next part where we're essentially going to capture how high the ledge is relative to our actor's position. So we're going to be checking the height of the obstacle to see if we need to climb or we can mantle, vault, hurdle, whatever, right? So what we're going to do is we're going to grab our traversal check and we're going to break it. Just like that. Make sure to hide all the pins, and then we are only going to pull our front ledge location in here, just like that. So then what we're also going to drag in is our actor location and the capsule half height. So from here, off of your actor location, go ahead and get a subtraction node and then split the pins on the second input. Because what we're trying to do here is by doing our half height, connect that into the Z, and we're trying to get the location minus the half height. So wherever we're located, or at least the Z vector of that, we're trying to subtract that Z vector. So ultimately here, by doing this subtraction node, we are going to be getting a negative number already starting out. So say we're like our height in the world is already at 0. So, you know, when you start out and your character's at 0, 0, 0 for your actor location, then that capsule half height, what that's going to end up doing is then we're going to be at 0, 0, negative 90 when we do that. So we're basically setting ourselves below the level here. So in saying that, what we're going to do now is we're going to get another subtraction node, and we're trying to subtract our location, our front ledge location, from our position. So I know it's going to be confusing of why we're doing so many subtractions, but I'm going to show you how we then fix that. So again, we're getting our location and we're subtracting our capsule half height on the Z to where it basically puts us lower. So then where our front ledge location is, or whatever our result is from that, we're then, wherever the XYZ location is, we are going to subtract that from our height or our location. So we're going to go further into the negatives. Like, so basically this is how we're going to be calculating the height. So off of that, with the input, we're going to split that structure pin. And what we're going to do is off the Z, we're going to get an absolute float. So if y'all recall an earlier video where I briefly talked about absolute float, is that essentially what we're doing is converting the Z into a positive integer. So say we're already at, you know, -90 to begin with, and then we further subtracted. So let's say our block height on the Z was, say, 300, right? So then we're going to be in -390 because of that. So in doing that, doing this with the Z by converting it into a positive, we now have an obstacle height of 390 instead of -390. So basically, in simple terms with math, it's how far away from zero that value is. So if you're -390 or you're positive 390 away from zero, you're regardless 390 away. So what this is just doing is making it always positive in that sense. So with that being said, go ahead and grab your traversal check result, and we're going to drag off and we're going to set our members. And what we want out of here, these set members, is the obstacle height. So go ahead and look for that pin, and you're going to set that and connect your absolute float into the obstacle height like so. So now that you've done that, we've essentially finished the second step. So I'm going to go ahead and copy paste my comment box for you guys to copy down if y'all wish. And what I'm also going to do is I'm going to connect the branch node from our previous step into the set members, just like that. I'm gonna set it up a little bit just so I don't have to do too much there. And I'm gonna move that over. And then prettify the pins real quick. There we go. Alrighty guys, so now we can move on to the next step. So now we're going to be doing the second capsule trace in this series. So basically what we're trying to do here, so we have a check here for our capsule trace that is basically, you know, what we're trying to do is look to where the front ledge is, where the direction is, and where its location's at, and then saying whether or not we have a front ledge or not. So if we out the true, we then look for the height of the level block or the obstacle, and then out of that, we're now going to do a new trace where we're going to then check from the front ledge location to the back ledge location now. So basically, if I bring over the visual, so now what we're looking for here is the back ledge. So now we're going to be starting from here wherever our last point left off, and we're going to then do a similar principle where we look for a slight offset over here and then indicate that we have a back ledge. So we're going to sweep across here, the top part of the block. So now what we're going to do is I'm going to go back over here because luckily we can pretty much copy this, the first part of the trace, and move it over. We don't have to redo anything. But what I am going to do is I'm going to delete these comment blocks for the moment because we got the gist of what they are, but I also have additional comment block, like an additional comment block to kind of encapsulate it all in one. So I'm going to go ahead and move that over. All right. So in our break traversal check result, however, what we want to do is we want to hide those pins. And like I said, we want to look for the back ledge location and the direction, so the normal. So just again, to reiterate, similar to the front ledge trace, here we get the back ledge location and the normal or the direction ledge is facing. The back normal will then be scaled by the capsule radius plus 2 units to push it away from the ledge to give us a small buffer to then avoid clipping. And then the same thing with the capsule height is we'll do a 2-unit buffer away, like upwards from the block or the ledge location. So then off of that, what we're going to do is the location, drag off, and you're going to get an addition node. And same as we did with the other one, we're going to give it a 3rd pin, and we're going to split that addition pin on the 3rd input pin. And then on the normal, we're going to look for a multiply node just like that and connect it into the 2nd input pin of the addition. And then off of that, what you're going to do is then plug, did not mean to do that. We're going to convert this to a float right here on the multiply node and throw in your capsule radius just like that, and I'm going to move that up, and then here for your capsule half height, throw it into the Z in the addition node. So when we look at it, if we go back, you'll see it's the exact same thing that we did here. I only redid these is just because I wanted to show you what we're doing again, where basically how we're setting it up again. So in doing that now, what we want to do is you're going to right click off of here and you're going to promote to local variable. However, like I said earlier, I forgot to delete the variable so I can recreate them with you guys. So what you're going to then recreate, and I'm going to drag it off here and set it, is you're going to do has room underscore check back ledge location, and that's going to be off that pin. So just like so. So now what we're going to be doing is let's go and grab our capsule trace by channel and make sure it's not the multi one. And you're going to, from your has room check back ledge location, you're going to connect the execution pin in there. However, from here, you're going to then drag out your has room check front ledge location, and this is going to be your start point. So as I mentioned earlier, what we're doing is we're trying to start the next trace from the front ledge of the level block and sweep across the top to then our back ledge location, just like that. So you can see how I connected it here. So then once you do that, go ahead and grab your radius and your half height, and you're going to plug radius into radius and half height into half height. Set it as so. And then let's go back into the first trace, and we're going to grab the debugging stuff, because I told you that we're going to be doing 3 different traces and it's going to use this every time. So expand your capsule trace and throw in to the enumeration into the debug type, and then your duration into the draw time, just like that. So now essentially we have completed the first part of the second capsule trace. So now what I'm going to do is I'm going to drag from the set members in our previous step into here. And then what I'm going to do next is we are now going to work on the next part of it, which is another check. So you're not going to split the out hit here, because what we're trying to do is we're doing a complete sweep of the top. So if I split these, so don't copy me, if I split these, we're seeing if anything blocks us, we're seeing if anything overlaps, we're getting a time on our hit, if the distance of the hit object, the location of the hit object, the impact point of where we hit that object. We're getting all of these, the name of the object, the bone name, whatever, the component it is, of what we hit, right? So we want all of that within our check. So what you're going to do is on the out hit, you're going to right click and you're going to do promote to local variable. And again, because I've already have these, I'm just going to drag it out here and set it. But essentially what you're going to do is you're going to call it the top sweep result, because what we're doing is we are sweeping for everything listed above, because we want to make sure everything checks out, that we get exactly what we're looking for, or return nothing, or all false stuff, whatever, to ensure that nothing is on the top and that we can safely maneuver over or vault over, climb over, mantle over, etc. So then the next thing that we're going to do is our return value. So, you know, if we're going to do a not boolean here. So essentially what this is doing is it's going to invert our trace result so that the branch node continues the function as if there is no hit. So if there is room to move across. So if we do not hit anything, then it's going to basically we return true. But then if we do hit something, then we're going to do false and fail the check. So off of that, go ahead and hit B and left click to get a branch, and we're going to connect the branch into here and then our not node into here. And then let me grab my comment for y'all to copy down. So again, copy this when y'all are able to, or pause it for a moment to copy this if y'all need to. And I'm going to move things over a little bit because now we are officially done with this part. So I can go ahead and put the big chungus comment node in here. I'm going to move that down just like that. And so let me get the comment and paste it in here. I'm going to move that briefly. I guess I can move it up a little bit. So let me move that up like that. Move it over a little bit. Perfect. And then I'm going to then close this off. So with our comment, so basically we're performing a trace across the top of the obstacle from the front ledge to the back ledge to see if there's room for the actor to move across it. So going back to it, I'm going to bring it up. So from our front ledge to our back ledge, we are sweeping through this top. So if there was, say, an obstacle on it or a block on it or a component on it, anything just on the top, then anything that we touch above here, we just automatically fail that check, and we're going to fail the traverse, and we're going to end up jumping instead. So that's what we're doing here. But then obviously if we don't end anything and we find the back ledge, then we are going to be doing the traversal action. So now what I'm going to do is let me prettify this up real quick, and we're going to continue on to the next part. So in this next step, there's going to be two parts to it. There's small parts, but basically this checks whether we continue or if we fail the check. So go ahead and grab your traversal check result, and then you're going to break it. And then in here, you're going to hide the comment pin. You're going to hide the connected pins, and you're going to look for front ledge location and then back ledge location, just like that. So off your front ledge, we're going to subtract, and we're going to add the back ledge location into the second pin. So basically what we're doing here is we're trying to set up the depth of the obstacle, because since if we've returned true and we have a valid front ledge location and then a valid back ledge location because nothing's blocking us, then we're going to subtract the front ledge from the back ledge location to then get our obstacle depth. So then off of the output, we're going to then get the vector length, and we're going to do vector length XY because we don't care about the Z part. We want the flat plane, so our XY value or wherever our block is, because essentially when you look at the block, so if I bring it up, you can see where our Y is here and where our X is here. So basically what we're trying to check is we're combining both of them to make sure that, you know, the entirety of this plane is free, but essentially we're trying to get our Y and then our X sweep done, so that way we do it, if we succeed in the check, right? So go ahead and grab your traversal check result again, drag off of it into set members, because now we're trying to set the obstacle depth. So go ahead and select that pin and connect the vector length into that. So with that being said, we are done with the first step of this, and this is going to be based off of the true value of our branch node. So off of our true branch from our previous section, go ahead and connect that, and then prettify the pins if you want to, just like so. And then for our false, what we are going to do is we're going to then, I'm going to copy this, set it here, And we're just going to get rid of the back ledge location, because this is if we don't find the back ledge. So what we're also going to grab is our sweep result. So, you know, the value that we set here, or the variable that we set here, you're going to get that and you're going to drag off of it, and you're going to do a break hit result. And I'm going to move that out a little bit just so you can see, because we're going to recollapse it. So basically off of here, we want to grab our impact point and subtract that from our front ledge location. Because what we're trying to do is we're trying to look for where we've impacted the obstacle when trying to do our top sweep of the level block. So like I mentioned earlier, so if I pull it back over, when we do our trace from our front ledge right here, if we hit anything after doing a sweep here, like say there was a small wall like right here, and we hit that, we're trying to get the location point of that impact and then subtract that from our front ledge location, and then that will be our new obstacle depth to see whether we traverse it or not, or if we have found the back ledge to do a proper vaulting, mantling, etc. So if we do encounter that, then yeah, we will fail the check. So now what we're going to do is same thing up above. We're going to drag off and do a vector length XY. And then we're going to then also grab and copy this and paste this here, because we are then going to then send our return value of our vector length XY into our obstacle depth. And then off of the obstacle depth, so actually from here, drag out, because for us to get another set members node is we have to get it off of here, or we have to right click into the blueprint to get another set members node. But it's just easier if we drag out from here to do a set members and then disconnect the pin, because we want to do a second one off the disconnected off of it. Or technically we could have just done this again. So do it however you want. Regardless, it still has to be connected. It's just cleaner if you do it this way. Or I could have just done it better and just dragged out another traversal check and set it. But in your set members here, what we want to check here is the, where is it? The has back ledge right here. So, because what we're trying to do is if we encounter something in between our trace from the front ledge to the back ledge, then we want to say that, hey, we didn't find a back ledge because there was an impact point in between the front ledge and the back ledge, just like that. So then once you have that, we are basically done with the next part. So off of, so let me grab the comment for y'all to copy down when y'all want, or if y'all want. And let me move that. And go ahead and drag the false pin from the branch in the previous section into here. And then I'm just going to clean up the pin. Just like that. And now we are done with that part. So I'm going to go ahead and grab these. Oop. Let me grab these, and I'm going to move it up just to have them neatly organized. And now for our final part, what we're going to do now is we're going to be doing the final capsule trace of this series, or this episode. So now, if we look back at the level block, what we have done now is we've set up our actor location and our trace forward distance to see from our character to see if there's a front ledge. Then in our second part, we have went from detecting that we have a front ledge location to then doing a sweep across the top of it to make sure there's no obstacles or overlaps, to then verify if we have a back ledge location, and if we do, then we check off that we have it, and then we can proceed to the rest of our traversal check. So now what we're doing now is we are going to be checking our back ledge to the floor, because this is going to determine what traversal animation montage will be played. Because say we have a high floor, right? We're going to do a vault. If we have a small floor like this, we'll probably do a mantle or a hurdle. if we have no back floor, and let's just say you had to do a climb and then it's just a new platform that just continues up here, you know, then we don't have a back floor and we need to do a climbing animation instead, right? So that is essentially what's going on there. So going back to it, what we're going to do now is our final trace. So here, and this is going to be kind of big, and just kind of follow along for the moment. It's going to be kind of confusing how I set this up at the moment, but I'll explain it at each step. Go ahead and drag out your traversal check result, and you're going to then drag off and break that traversal check result and hide the unconnected pins. So what we want out of here is we want the back ledge location, the direction of our back ledge, and the obstacle height. Because what we're trying to do is get certain offsets to be able to end our trace to find the floor. So off of here, let's go ahead and grab our capsule trace. So that way you can see how we're setting this up. So do capsule trace by channel. And here for the start, grab your has check back ledge location and go ahead and plug that in there off the start. And I'm going to move that out of the way for the moment just because of what else we're doing. So off of your back ledge location, drag out and look for an addition node. And then off of the output of the addition node, grab a subtraction node, just like that. And then connect the output of the subtraction node into the end. So I'm having you set it up like this first because there's going to be a little bit of like roundabouts that we go through where I don't want to confuse y'all, but I want to show you what we're connecting and what offsets we're providing to get the back floor. So starting at the first part, what we're going to end up doing is we're going to grab our back ledge normal or our direction, and we're going to get a multiply node. We're going to connect this multiply node into this addition second input slot, just like that. And we're going to grab our capsule radius and we're going to grab our capsule half height. So off of our capsule radius, we're going to do an addition node, and just like before, we're going to give it 2 units. So basically, and then what we're going to do is convert the multiply node and connect our input there. So just like we did in the first 2 capsule traces, is we're trying to offset, let me drag it over for y'all. We're trying to offset away just a little bit from the ledge. And this is not really for clipping or anything, it's just to kind of get a buffer away from that, or our scalar buffer. So just kind of like how we did it in the previous ones. However, with the capsule half height, it's going to be a little bit different. So with our subtraction node, I need y'all to split the struct pin so that way we get the XYZ values, because we're going to be tampering with the Z because we're trying to look for the floor. So we need to go down, right? So off of the capsule half height, you need to grab a subtraction node and connect the half height into the second one. I'm sorry, connect that into the second pin. And you're going to grab the obstacle height and connect it just like that into there. So let me go ahead and move some stuff out of the way so you can see what we're doing. So we're trying to now subtract, so wherever our obstacle height is, or how high our obstacle is that we got earlier in the video, we're now trying to subtract our capsule half height from that obstacle height to try to locate the back floor. However, what we're also going to do is off of that, we're going to add, and we're going to add 50 units. So essentially what we're doing is, let me grab it, is with this trace, with the back ledge to the floor, what we're trying to do is get the obstacle height and subtract it to where we either go below the floor or a little bit below or equal the floor. That 50 buffer is going to bring us up so that we're just ever so slightly above the floor, so there's no clipping into the floor when we do our in trace or our in motion or in traverse animation. So that's what we're trying to do there. So Go ahead and connect this part into that Z, and then there we go. We have our end location of our trace. So let me go ahead and move these around real quick, because what I'm going to do is I'm going to get y'all to the comments for y'all to copy if y'all desire. I'm going to move it out like that. And so for the capsule radius section, there we go. And let me buffer it up a little bit. And I'm going to move the break back a little bit. And then for the capsule half height, grab this comment for y'all. Just like that. And then let me prettify the connection pins real quick, just so I can move stuff around. And what I'm going to do is I'm going to actually, did not mean to do that. I'm going to, let me clip that again. I'm going to actually make these go around. That way I can just move the box accordingly. All right, so just like that. I know it looks kind of a mess, but I'm trying to use reroute nodes to clean it up ever so slightly. So then our comment here for our the start of our downward trace from the back ledge location into the floor. And then here's the next comment for y'all. So that way you could see what's going on here at the addition subtraction node. So again, the back ledge location is our base point, you know, starting from here. The location is adjusted by adding and subtracting certain offsets. That way we can cover where the floor is located. And then with that, let me go ahead and move that in, prettify that. All right, so now we essentially have that set up, and then same thing that we've always been doing is let's go ahead and grab our capsule radius and our capsule half height and plug that in radius into radius and half height into half height. Oop, not mean to move that out. And then we are now also going to grab our debug, and we are going to move it, copy paste it over here. Oh geez, didn't mean to mess all that up. Okay, there we go. Actually, I'm gonna do is move these back ever so slightly, or more than just ever so slightly. Or actually, what am I doing? I could just do this. Oh, I thought I had that covered. Like that, move the radiuses and stuff into here, move the debug up a little bit, and then plug your debug into the draw type and then the duration into draw time. All right, guys, so we're on the final stretch of it. So now what we're going to be doing is we are going to now set up our final check, you know, to determine if we have a, you know, the back floor or not. So what we're going to do now is we're going to split our out point, because there's going to be one certain point that we want, which is the impact point. And what we're going to do is I'm going to just grab all of the nodes that we need first. So I'm going to get our branch, and I'm going to get the traversal check, and go ahead and copy paste this traversal check 2 more times. I'm going to move these up here for our true and false, and then down here is where I'm going to start. So on our first traversal check, drag off of it and do a break check, and then hide the pins. And then with the pins that we want the back ledge location, just like that. And then from our impact point normal, or no, I'm sorry, our impact point, not normal, the impact point, you're going to drag off down to here and grab a subtraction node, and you're going to plug our back ledge location. Because essentially what we're trying to do is we're trying to then get our back ledge height. So, which you'll see here in just a moment. So wherever our impact point is to the floor, we want to subtract the ledge location from that to basically get the height. So I'm going to split the struck pin here, and what we're going to grab is the absolute float. So like I said, we're trying to find the back ledge height, but what this ends up doing is for wherever the floor is and where our location is, what essentially is going to happen is like, okay, our impact's on the floor. So say like our impact is 10, 5, or 0, right? And we're subtracting, let's say the back ledge location is on a Z of 300, right? So then we're going to end up getting numbers like negative 290 or negative 295 or negative 300, you know, like with the numbers that I threw in there earlier. So what we're trying to do is once we get that Z, we want to then convert into an absolute float. That way we end up with a positive number for our back ledge height, which we'll be plugging in shortly. So now go ahead and plug the branch into the execution pin and get the blocking hit and throw that in the conditioned, because what we're trying to check here is to see if anything is blocking our trace to the floor. So if there is, then there's no floor, or we don't discover a floor, and maybe we'll be doing different animations, or we'll probably fail to check. But since we're at the last point, what we're ending up looking for is to determine if we have a floor, then we can mantle, hurdle, whatever. But say our floor is pretty deep, like it's so far down, then we're gonna end up vaulting. Or if we don't have a back floor at all, then we're gonna end up climbing depending on the obstacle height. So that's what this check's trying to do. So off of your traversal check result, go ahead and set members, and we're looking for has back floor, because if something is blocking us or we don't find a back floor at all, then that's what we want to do, is we're essentially like failing the back floor check to then determine what secondary animation we'll be playing. So then off of this traversal check result, go ahead and drag out and do a set members of the traversal check. And off of here, we're going to do has back floor, then we're going to do back floor location, and then we're going to do back ledge height, just like that. So our impact point here, we are going to drag out and do our back floor location. So as I was mentioning earlier, essentially since we're doing the downward trace now and we're looking for our floor, if our impact point discovers the floor, then we're going to return that impact point location as our back floor location. And then just like what we've done into here, where we're trying to get the height of that, you're going to plug that into the obstacle height now. And then finally, what we're going to do is we're going to plug in our true value here to our set pin, and we're going to mark has back floor as true, because we've discovered that we have a back floor, or the floor behind the traversable level block. So that is pretty much it, guys, for this. So let me go ahead and put out my comment node for y'all to copy if y'all wish. You know, pause the video, take a moment to copy it down. And let's see, it's going to take a bit for me to get these comments to y'all. So I don't want to skip anything. So if I do end up going quiet, it's just because, like, hey, I don't want to over ramble. That's just pretty much kind of it for me. And let's go ahead and set that in here. So let me just grab it like this and move that here. Move that up ever so slightly. I'm gonna just move that and then move that here. All right, and then I'm gonna grab, this is gonna be a big block. When I look more at this comment block, it's basically just kind of like duplicated. I guess I didn't realize that I copy pasted twice pretty much, or basically rewrote the same thing. So if y'all do pause this and, you know, try to copy down the comment nodes to see what's going on, just copy the first 2 sentences that you see, because that's pretty much like what's going on. And actually, because of how this is twisting, let me just do this instead. And I don't like how that did that. All right. So I'm just going to do that instead. Either that or I can probably just push it out, but no, I don't like that. I'm going to do this instead. I forgot I could just do that. Make it look nice. All right. So let me grab the big chungus comment block for you guys. And then we're gonna go over this briefly. Then I'm gonna set that to group move, and then let me move that back up to here. And now let's go ahead and from here on our previous step, let's go ahead and set our member connection to the capsule trace. And again, I'm just gonna prettify the connection points. Just like so. So, if we go back through this, guys, which is what I'm going to do real quick so we can recap what we did in this episode, is what we did first is we checked if our traversable level block was found, right, or it was valid. So in our previous episode, we did an initial trace to see if there's a level block in front of us. Since that's true, then we're going to continue on. If we failed, then we fail the traversal level check, and or the level block, and we're just going to jump. So then our first capsule trace that we did in the beginning is we looked from where our actor was located. So let me just focus more on this rather than what we're doing. So we looked to see where our actor was located, and we set whether we have a front ledge location, or we checked to see if we have a front ledge location and tied it as our endpoint. We then set the radius and the height of the capsule that we'll be using for our trace, you know, for when you actually do see the debugging. And then going out of it, if we don't hit anything, nor do we overlap with something, if both conditions are false, then the nor will return true and we'll continue on. If either of those are true, if we hit something or we overlap with something, then we're going to fail the front ledge check and we're going to fail the traversal check. Then into here, what we ended up doing was we started looking for our obstacle height, and we got that by getting our actor location first and subtracting our capsule half height. So like I said earlier, it would be probably like -90 because of where we have the capsule half height located. Then wherever our front ledge is located due to our initial trace, we then subtract what we got in here into that, so we would have an even bigger negative number. However, we convert that using an absolute float, so it's a positive number, so that way we know that the obstacle has a huge height, like above the plane or our floor, so we know how tall the object is. Then we fed that into here, where we then checked, that we have a front ledge location, so our start point, and we checked to see where our back ledge was located. And then outside of that, we did an entire sweep across the top because our start point was our front ledge and our end point was our back ledge location. We did an entire sweep on the top to ensure that nothing messed with our traversal or the ability for us to traverse. So if there is no room or there's an obstacle, we're going to return the depth and we're going to fail the check, or at least fail that we don't have a back ledge. So this might indicate that we're climbing as well. So it's not like we necessarily failed the check. It's just, hey, we might not be doing a vault, hurdle, or mantle. We may just be climbing instead because, there is no back ledge to follow up on. However, if there is a back ledge that we can follow up on, then we save the depth and we continue to our last trace, where what we ended up doing is we looked for our back ledge location, and then we did more offsets to then discover where the floor is located, or the impact point of the floor, and that would be our endpoint. So if we have a back floor location due to our trace's impact point or wherever it impacted, then we're going to save that and look for our back ledge height with that. So that way we can see like, hey, do we need to vault because our height is too big, or can we hurdle because our height is small, or can we mantle because it's, you know, big enough for like average size, right? So if nothing's blocking us, then, and you know, if something is blocking us, we fail that we have a back floor, and we may just do a climb instead. Or we may just like fall, right? We'll vault and then fall. But then if we do have a back floor, then maybe we'll do other animations. So that is pretty much the gist and the rundown, guys. I know that this was an extremely long episode, but I definitely did not want to break this up into multiple episodes when I thought about it more, because it's just better to be able to pause it and come back to it at different points to see what's going on. So now the last but not least part of this is go ahead and make a second or a third sequence point or index and drag that into our branch, and we are officially done with that. So go ahead and compile and save your work, and basically let me show you what we're going to be doing in the next section for the next episode. So we're going to be looking at, so now that we've set or updated those parameter points for our traversal check result, we are now going to grab all that updated information, and we're going to feed it through a bunch of branches and conditions to determine like, hey, do we vault here? Or hey, do we hurdle here? Hey, do we mantle? Or do we do nothing? Or maybe we climb, something like that, you know? And then we'll feed it into debugging. When we get through this will be off by default, but I will show y'all how we will be getting these in either the next episode or maybe the episode after that, because I don't know if I want to make both of these sections a single episode or just focus on this being its own episode. So what I might do is focus this on being its own episode, and then we'll get into the final part in a fourth episode, and then we'll go over the debugging. So other than that, guys, that is it for this video. If y'all stuck with me until now, thank y'all very much. I appreciate it. If y'all did like this, then I hope that y'all tune into the next episode. So definitely look forward to that. Just a fair warning, I might as well disclaim it now, that I probably will not be showing the animations or how to set that up quite yet. So what I'll probably end up doing is just like this, is setting it up to where it just ends here, because technically there's more stuff that goes on into here, like montages, etc. But what they're doing is they have those montages and stuff set up in the animation blueprint, and I haven't yet been through all of the animation blueprint, because I feel like after this series I'm probably going to take a bit of a break just to be able to work on the animation blueprint, but also get another tutorial series that I want to get out with, like a Pong tutorial or something, because after going through this, like going through, you know, simple projects and stuff like that, have really opened my eyes. So, you know, stay tuned for whatever I do then. But until then, guys, please join me in the next video. I will see y'all then. Take care. Bye.